Hey, welcome back, everybody. Happy Monday. Hope you did well on the weekend. Finish this up on Friday afternoon before you even started your weekend, so you don't have to worry about it. Let's see how Edgar Degas, the famous French artist, did on his homework, right? So that first one I did for you, right? 4 1/3 is the same as 13 thirds. And we even double checked it and went from 13 thirds and went back to 4 1/3, right? 15 fourths, I'm going to divide the bottom into the top, and 4 goes into 15 three times. 3 times 4 is 12. Now, remember what I do? My remainder goes on top, and what was on the bottom when I started, that 4 goes on the bottom. 4, 3 and 3/4. Want to double check? 3 and 3/4. We use the C method, right? 4 times 3 is 12, plus 3 more is 15 over what? What was on the bottom is on the bottom. That's how we got. Okay. 3 1/2, we're going to use a C method. And 2 times 3 is 6, plus 1 is 7/2. Double check. 2 into 7 goes 3 times. That's 6. Your remainder goes on top. What was on the bottom goes on the bottom. Back where we started. Must have done it right. 8 into 15 only goes 1 time. And my remainder goes on top. Divisor goes on the bottom. What was on the bottom goes on the bottom. 1 7/8. Okay. All right. Hopefully you did well on that. Remember, of means multiply, and multiplying fractions is what? Hopefully you yelled out easy, right? You are so glad when you see that multiplication sign in front of fractions, so you don't have to worry about common denominators. Okay. Now, 2 times 3 is 6. 3 times 7 is 21. 3 goes into the top and bottom, though, right? 3 goes into 6 twice, and 3 goes into 21 7 times. Now, check this out, because you could do something on multiplying fractions called cross cancel. Okay, there's a 3 on that goes in the top and the 3 that goes in the bottom. So I could have said 3 goes into 3 once and 3 goes into 3 once and simplify before I multiply. Then I got 2 times 1 and 1 times 7. I get your answer, right? Now, why does that work? Because when you multiply fractions, I'm going 2 times 3 on top and 3 times 7 on the bottom. Couldn't I do 3 times 2 on top? Isn't that the same? And if I do 3 times 2 on top, isn't that the same as going 3 over 3 times 2 over 7, right? I just switched the tops. Check this out. 3 over 3 is equal to 1. 1 times 2 sevenths, 2 sevenths. Okay. Now, I'm just showing you that's how and why you're allowed to do that. And that's important. But remember, you can cross cancel if you want. Okay. Now I can't cross cancel if I have like a 5 here and a 20 here and say 5 goes into 20. One has to go on the top, one has to go on the bottom when I'm cross canceling. Okay. All right. Easy enough. 1 times 3, 2 times 5. Boom. I'm done. See ya. Okay. How hard was that? Okay. 17 times 10. I'm going to move the decimal over 1 spot, get 170. 17 times 100. I'm going to move the decimal over 2 spots, get 1,700. 1.7 times 1,000. Now I'm going to move it over 1, 2, 3 spots, right? It started between the 1 and the 7. 1, 2, 3. I get 1,700. Okay. 68 times 100 is 6,800. 6,800 times 100, move it over twice, I get 68. Okay. And 6.8 times 1,000, move it over 3 times. It was here. I go 1, 2, 3. Now, why is there writing on here that wasn't there when you finished the video on Friday? Because one of my students did some work on this, copied everything she could, but she was stuck and wanted me to explain this. So she came to my afternoon Zoom, which is like giving me cookies. And I was very happy to help her. And then she was able to get her homework done on Friday. Okay, try that sometime. 5-27, we're talking about on your graph paper, draw a rectangle with a width of 6 and a height of 8. Okay, and I just pretended these are centimeters and said that's 6. That's how wide it is. It's 8 tall. And then it says draw a similar rectangle that's enlarged 300%. Now, what is 300%? We figured this out. It's 3 times, right? 3 equals 300%, right? Move the decimal over 2 spots. Okay. So I'm going to go 3 times as big. So instead of 6 wide, right, each of these ones is going to be 3. 6 times 3 is 18 wide. Instead of 8 tall, it's going to be 8 times 3, 24, right? Now, do I have that much room? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 24. Oh my goodness, I'm going to be on top of this other rectangle. Oh, but I got to figure out what 18 is, huh? 3, 6, 9, 12, 15, 18. Oh, I'm going to go through these little holes for the binder paper, huh? Yeah, I just gave myself enough room. Okay. Now that is 18 wide and 24 tall. Okay. Excuse me. All right. So the next part of that question, it says you want to draw, now it's 2/3 of the original lengths. What is 2/3 of 6? Well, what does of mean? Times. 2 times 6 is 12. 3 times 1 is 3. 3 goes into 12 4 times. So instead of being 6, it's only going to be 4. That's how wide it is. Okay. 1, 2, 3, 4. Instead of being 8, 8 times 2 is 16. 16 thirds. I got to divide the bottom into the top on that. 16, 3 goes into 16 5 times. And my remainder goes on top, divisor on the bottom. That's going to be 5 1/3 tall. How do I do that? 1, 2, 3, 4, 5. And I'm just going to go 1/3 of the way to the next one. Less than half, right? We're going to call this 5 1/3. Make sense? All right. 5-28 on this one. Okay. Remember, she claimed that whenever she increases the perimeter of a rectangle, its area increases. So she said, if I make the base twice as long, then the area increases. Is her statement correct for this figure? Well, we did it. The area of this was 18, and I made this base twice as long, 12. The area of this is 3 times 12. Well, that's 36 square centimeters. That's true for this rectangle. You got to be careful, though. Okay? A broken clock is right twice a day. What does that mean? If your clock stopped at 3:14 and it never moved, well, it would be wrong right now because it's the morning. It would be wrong while you were sleeping, except at 3:14 in the morning, it would be right. And at 3:14 in the afternoon, it would be right. So you got to be careful thinking that just because it worked this one time, it's always going to work. Okay. Okay. Now, but for this one, she's right. If I just increase the length, then I'm going to have a bigger area. Okay. Now, is her claim about the relationship of area and perimeter correct for all figures? For example, is there a way she could have a rectangle with a greater perimeter than this, right? The perimeter is 18. Greater perimeter, we want to make the perimeter bigger, but with the same area. The area is 18. Is there another way of getting the area of 18? Yeah, I can have something that is 2 tall and how wide? 9. If it's 9 wide and 2 tall, the area is going to be 18 again. But what's the perimeter going to be? 9 plus 2 plus 9 plus 2. The perimeter now is 22. instead of 18. So the perimeter got bigger, but the area stayed the same. Okay. Now, how about this one? What if I had one that was 1 tall and I don't know how wide this is. Let's see. 3, 6, 9, 12, 15, 16. 16 wide. What's the perimeter of this? 16 plus 1 plus 16 plus 1. The perimeter of this is 34. What's the area? 1 times 16. So here the area got smaller, but the perimeter got bigger. Okay, so her statement isn't always true, huh? Okay, and that's what you wanted to know. Sometimes it works, but not always. If you keep the same height and make it longer, then the area will go bigger. Okay, all right. Have a good one, everybody. Enjoy the rest of your Monday. Hopefully you did well on this. Good luck on that next one, 5.1.4. That's a fun one.